Hello and welcome everyone to another episode of Video Analytics 101 interviews. We do this once per month where we interview industry leaders in video analytics to talk about different aspects of different topics where video analytics are being used. In the fall, we have a big focus around traffic and vehicles and traffic management. We had a license plate recognition 2 months ago, and last month we had a conversation with Sprinks around video analytics and traffic management. So if you haven't seen this, check it out afterwards. Don't forget to subscribe to this channel as well if you don't want to miss anything in the future. And today we're continuing with our traffic topic. We're talking about how to improve passenger safety with video analytics. And I'm super happy to have one of the pioneers in this field with me today. Florian is the CEO and founder of Emotion 3D. So welcome, Florian.
Hi, Florian. Nice to be here.
I really like your name. So thank you for coming and thank you for doing this. It's really exciting because this not only is something that's very specific where video analytics are used in a very interesting environment inside of the car, inside of the vehicle. And we hear from time to time that vehicles are becoming basically small data centers or small computers. So it would be really interesting to hear about the technical aspects of it. But it's also exciting because from an application point of view, it affects almost everyone. So if you have a car, or if you will have a car, or even if you're driving an Uber, likely this technology will affect you today or sometime in the future. So it will be really interesting to talk about what can we do with video analytics. Let's start off by getting an overview of what Emotion 3D even does. So maybe can you give us a short summary? What does the company do?
Mm-hmm. Yes, of course. So Emotion 3D, we are a software company based in Vienna, Austria. Our focus is on software development for the automotive industry with a dedicated focus on, I would say, human analytics. Yeah? So it's all about understanding what humans are doing inside of cars and in the close surrounding of cars. And this is used for a lot of applications. Yeah? But the specialty is we're really looking at the interior of cars, and it's very important to really know what's happening inside of a car for, I would say, 3 reasons. And this is also where most of our applications are located. On one hand, it's about safety. Yeah? The more you know, for example, about the driver, if he's falling asleep or if he's distracted, the more you can intervene and prevent accidents. Yeah? So actively preventing accidents. On the other hand, we are working on applications where you protect the occupants very individually using, for example, 3D cameras that you can measure, where you can measure each occupant precisely. And when a crash happens, we can then provide very precise information to the airbag system. Yeah? So it can really personalize the way it's working and for improving the safety and the protection throughout an accident. Second thing is this information is very much useful for user experience. Yeah? So the better the vehicle knows how to interact between the occupants, for example, gestures, adaptive illumination, and other applications, the more intuitive and the better the user experience for the occupants is. Yeah, so here we also have a very dedicated focus on these functions. And the third topic is normally automation or operational efficiency. This is very important. If you imagine, for example, an autonomous shuttle, it's very tricky. It's driving around alone, and typically, if you have a human driver, he's doing a lot of useful things. And if the vehicle is alone, then it has to take over all these things, for example, like detecting medical emergencies or violence or vandalism. Also, for example, if a vehicle is clean. And these functions also require a very precise understanding about the interior and what the humans are doing. And we are providing software functions for exactly this.
And you're providing software solutions to car manufacturers, right? So you're a supplier to car manufacturers.
Yes, it's a little bit trickier. So our core expertise is really on the software development. So typically, our customers are not the vehicle manufacturers, but the big suppliers that are providing submodels or sub-functions to them. We're providing software stacks that our customers, so normally large suppliers, can license from us. Yeah, they build sub-modules that consist of normally like a processing unit and a small 2D or 3D camera. And then they package this together with our software stack and sell this on to the vehicle manufacturers.
Okay, so it's something like an integrator that then delivers the full solution to the user.
Exactly.
Okay, this is interesting. You talked a little bit about the applications already. My understanding is you have these 3 topics around safety, entertainment, and automation. Maybe let's dive a little bit into this. Can you give us, for each of those, like very concrete ideas, what does it do and how does it improve safety, entertainment, and so on for the user?
Yes, of course. So maybe let's start with two examples for safety. For example, drowsiness, drowsiness detection or distraction warning are very concrete examples how drivers can be supported when you drive for hours. And it's very typically for passenger cars, but also, for example, if you look for commercial cars, if you have a truck driver, he's driving around the whole day, it's very likely that he gets tired at a certain point. And our software stack measures precisely the eye openness, for example, the gaze direction, the head orientation, and the head movement. And based on this information, we compute, for example, drowsiness scores and attention scores. And then we can warn the driver when the system believes that there's some situation where it's already getting dangerous, or he should, for example, take a break. For airbag deployment, it's a little bit differently. Here, we typically use, for example, a 3D sensor for measuring the bodies at high speed with over 100 frames per second. And we provide information, for example, where your shoulder positions are. We measure your body size. And this is very important because now, currently, airbags are quite stupid. They don't know much about the occupants they are protecting. And they have to assume like an average person with an average size. But of course, people are all different, larger, smaller. You have male drivers, female drivers. And it's very important that the system can adapt to the specifics of the occupants. And that's where we coming into place again. We measure precisely the size, the shoulder positions, also the head position and how fast the head rotates, for example, when a crash happens. And these are all information that the airbag can then use, the airbag system can use for deploying differently for each occupant. And for example, the distance between the occupant and the airbag. For example, if it's 1 meter or 20 centimeters, the airbag can trigger with different force. And there are a lot of other options. And this is a very concrete example of what we're doing in this direction.
Is this being done today? I mean, this sounds super advanced.
No, not yet. But I think that's there are already some regulations which have adaptive airbag control or restraint control on the agenda, and this will come sooner or later, and also like internationally being rolled out. But there's no concrete regulation yet. It's different. Okay. For example, for driver monitoring, there are concrete regulations. These are must-have functions in all the upcoming cars in the near future. To have the distraction warning and drowsiness warning integrated in newly produced cars.
So you're saying that in the future, every newly produced car is required to have the safety features?
The drowsiness and distraction warnings, they will be required to have these.
Wow, cool. Okay.
Yeah. And
so this is safety. What about the entertainment? What are you doing there?
Yeah, so this is quite a wide area. I would say it's all about user experience. So it's about interaction between the vehicle and the occupants. A very straightforward example is gesture recognition. But starting from a very simple level, for example, adaptive illumination of the specific areas in the car. If you put your hand, for example, to a specific area that's dark, that the car automatically illuminates this area. Adjustment of components like seats, that the seat automatically adjusts to your size, or the mirrors. You don't have to select mirrors, but it's automatically knowing which mirror you mean from your viewing direction, and many other features. And user experience becomes very important. If you look, for example, at a lot of new players like Sony or Apple planning to enter the automotive market, I mean, they are really strong in user experience, and they know exactly that they can do a lot more with intelligent sensors, and also provide the same user experience, a very high user experience that users expect from their smartphones. And if you look at cars, they're getting more and more like smartphones. You get big displays, you get a lot of applications, like a little bit like an app store system. And with this, also the expectations for user experience grow. And another example, for example, what we're doing is we can determine the gaze, so where each user can look at a display, for example, and this can be used for eye controlled display control, for example, or for adaptive content displaying differently if the driver or the co-driver is looking at a display, and many other things here. But you have a lot of capabilities because it's a very controlled environment. You know very much what people are expecting in terms of functions, and it's all about precise and robust sensing of the environment.
Okay.
And
the third one was automation, right?
The third one was automation, exactly. Yeah. This is if you look a little bit ahead for automated driving, automated vehicles. The closest thing I would see today are shuttles driving at a very low speed. I think passenger cars, it will take a far longer that these are getting mainstream, like fully automated. But for autonomous shuttles, this is there are a lot of projects already internationally for rolling out autonomous shuttles. And here you have a lot of functions. On one hand, it's for example making sure that not more people enter the vehicle than it's allowing to check if they're all secured before the vehicle starts driving off. To make sure if a medical emergency happens, that the vehicle calls or takes some actions to maybe call it emergency team or whatever makes sense, but that the vehicle is not driving around for a full day and not realizing what's in there.
And I guess luggage and these kind of applications as well. Yeah,
it's important to state that these vehicles, they normally also have a remote operator, which can connect to the vehicle, like in a lift. But you want to reduce the amount of the number of connections or the amount the operator has to connect as much as possible to really make this efficient. If he constantly has to be connected, it's not automated anymore. And this is a supporting feature that's supporting this remote operator and does a lot of things automatically, and only in case it believes it needs support remotely, then it asks for help or does some actions.
Okay. So let's talk a little bit about the technology. You mentioned, I think, already laser. What kind of sensors do you use to detect all these things? I guess there's multiple sensors involved, right?
Yes, I would say it depends a little bit on the use cases, but in most cases it's we're working. I mean, in most cases we're working with some active like 2D sensor with active illumination. So normally like an infrared sensor, for example, with some active illumination. Also, RGB IR sensors are quite common, where you combine near infrared and RGB. So you have one sensor, but you get the NIR information as well as the RGB information. And for the use cases or applications where you need a very high precision on like 3D location, for example, or where 3D information is very important, we use 3D sensors. And here, in most cases, I would say nowadays time of flight. Obviously, you also have other technologies, but I think time of flight is mostly used for the 3D applications.
Okay. So time of flight also means basically a lower resolution than what you get with the others, right? But it's good enough.
Yeah, exactly. Yep.
Okay. The other technology aspect that I'm wondering in this context is, I mentioned before that cars are becoming small data centers. Is hardware limitation, because with all the analytics, usually you need like big GPUs and all these kind of things which need cooling. How does it look like in a car? Which kind of hardware do you have, and is this a constraint, and how do you deal with it?
I think it's one of the strongest constraints we have, because on one hand, the processing typically has to happen in the car. There's 3 reasons. On one hand, it's privacy. The data cannot and shall not leave the car. That's also regulated, for example, by GDPR. Second thing is you have normally, you want the signals, the information always available. Even if you drive through a tunnel or through the countryside, if you have no internet connection, you want to have this information that you need for safety features constantly, and also typically with for some applications at a very low latency. So the processing has to happen in the car, and despite there are stronger and stronger processing platforms coming, normally you have to share the compute power and the memory with a lot of other software functions, and so it's very important that the footprint of the software is very small. So what we have is we have a C++ stack with a very small compute and memory footprint, which is very flexible in terms of porting different automotive platforms, from Renesas, from Qualcomm, from TI, NVIDIA, and this gives quite some flexibility depending on what the customer wants to use. He normally has some architecture that he's using or wants to use for a new car. And then we have to make sure that our software stack is really optimized to specific system architecture, compute platform, and the environment with other functions that the customer wants to use.
But I guess that means you cannot use all these standard models that everybody's talking about, like YOLO, whatever. You cannot use them, right? So you'd use different technology that's more efficient.
Normally, we start with state-of-the-art models normally, because there's so much going on always, and you always have to keep an eye on state-of-the-art. But then once the functions are very stable, you normally have to adjust and adapt and port these models that you have to product-ready platforms, and this normally requires a heavy rework of architectures, completely retraining the networks. It's frequently the case that these platforms don't support, for example, all types of layers, that you have certain operations not supported. So you have to remove these and then replace them with some layers or some operations that are supported. And so here it's normally requiring some rework of the architectures. But obviously we also look what's out there, and I think the space is moving very fast. So I think it's still important to keep an eye on the newest models and to see the ideas that are coming from there.
Yeah, I'm pretty sure it's a huge market. I know that when we are looking at data sets, so many data sets are for autonomous driving, and I could imagine that the same thing will happen for inside of the vehicles. And it feels like this industry is much bigger than our security industry, actually, because there are very few data sets that focus on our industry, and everything seems to be about vehicles and autonomous driving. So I'm pretty sure there will be lots of developments there, especially adapting to a specific use case. One final thing, maybe, I think you already mentioned GDPR and other requirements. Is this a special constraint in your area that you need certain certifications, or are there standards that you need to adhere to that limit you somehow in the way that you're doing?
On one hand, there is this focus of our company on I would say human AI, to understand humans. On one hand, you have some restrictions on the data. It's all about really measuring humans, and all the projects have to consider this aspect somehow. When you do real data capturing in the car, in the lab, and so on. That's also one reason, for example, why we use a lot of simulations. We have our own in-house in-cabin simulator for producing this data to reduce the amount of a little bit expensive and tricky to get human recordings. And on the other hand, you also have a lot of restrictions on the software quality. There are very tight standards, like for example, automotive SPICE or functional safety standards like ISO 26262 or cybersecurity that are very by very precise process. A lot of steps that you have to follow, and you have to for this you need to build up a lot of expertise. This is maybe especially challenging for smaller companies to really build up this workflow initially, but that's exactly what we are doing and what we already have in place to a large part, to develop according to these standards. And I think this is one core requirement if you want to build software for serious production cars. I think this is very important.
The interesting topic that you mentioned here regarding simulation, because it makes a lot of sense for privacy reasons, of course. But it's a big topic in general, synthetic data and how can we create synthetic data sets. Can you maybe give me a quick idea how you're doing this? Are you creating your own platform for doing this? Are you using gaming engines? Do you have a provider that provides you simulated data?
We tried a lot of different things over the last years. But we realized that external data providers don't work for us, because we see that for developing an AI product, you need fast iterations. You have to, obviously you can buy a data set, but normally then once you train, you have some shortcomings. Some things are not working. Normally with some analysis of the data, you get an idea what you would like to have in addition. But then I think it's iterations, fastly telling the provider what you need in addition, and then to really get these things back. I think this is often not working, and I think that's the reason why we decided to have this simulation part in-house. And here we are, I mean, obviously we are using existing game engines, like Unity or Unreal, but we develop our own simulation pipelines then in terms of really simulating sensors, sensor noise, sensor characteristics, the environments, human models, and also the variety that you have to do, and a lot of other things. But I think that's still quite tricky. I think this step that it really works for real data, that's very laborsome, and you cannot do this by not having such a fast iteration in-house. I think we see this ping pong between our algorithm development and the simulation team as very important and key, that you get this to work. Otherwise, I think it's not possible, because the AI team cannot communicate precisely otherwise what they need in addition in terms of what data, and I think you need this ping pong between the teams.
That's really interesting, because synthetic data, everybody needs synthetic data. It's a huge topic. There are hundreds of companies providing this, and yet I have to meet a single company that actually uses an external provider. Everybody is doing
Okay.
It's mind-boggling to me, because obviously there's a market, but no one fulfills the need of the market. It's crazy.
Yeah.
Okay, but that's a topic by itself, synthetic data. Maybe to finish off, can you give us a little bit idea, where do you think this is going? Like, what will we see in the coming years actually going into production? What kind of features, and where does it go in the longer perspective?
Mm-hmm. Now, there are a lot of functions that are going into production already. For example, next year, we have one SOP starting next year, for example, for driver monitoring functions. We see especially this active safety features for around the driver. These are getting mainstream. You will have cameras in every car, and with this, you will get a large demand for using this hardware for a lot of other functions, not only safety but user experience. And this is exactly where all the vehicle manufacturers are currently heading up. They want to use the cameras they're integrating now, because they must provide these must-have functions for drowsiness and distraction. And they want to have a lot more functions. And we believe this will push this understanding and these stacks that we're providing very strongly over the next years. Really starting this year, but also next year in a lot of serious production cars. And the airbag directions of passive safety, I think this is maybe a little bit further ahead. You need you have more requirements. You have longer development cycles here. But I think also here we can expect this in the upcoming years to be integrated. Overall, I think this understanding about humans is key, not only for the interior, also for the exterior. We believe there will be a strong need. Currently, it's only about, like, most people know about automated driving, from getting from A to B. But for example, in the close surrounding of a car, you have so many applications where knowing what people intend, if they want to cross the street, if they have seen the car, where they're moving, can greatly enhance the safety of especially vulnerable road users like pedestrians or bicyclists. As we believe, this human understanding, human AI topic will become key in the automotive industry.
Mm-hmm. Yeah, I totally can see that. I mean, there's so many things still to do, and that's not even talking about things like curbside management, where you might want to use vehicles to detect trash on the sidewalk or these kind of things. So it's a huge field that's opening up. Thank you very much for giving us an insight into this field. It goes a little bit beyond what we are usually talking about. It's not exactly security industry, but it's a big thing for safety, and it affects all of our lives. So yeah, thank you for coming.
Thanks a lot for the invitation.
So yeah, thank you again. It has been great. Everybody, we are taking a short break over Christmas, and we are coming back with something big, likely in February. But we want to rest a little bit over Christmas. Thank you for joining us. Thank you again, Florian. It has been great. It has been super interesting. And thanks for watching, and see you next time.
Thank you.